For the car resale value prediction project, we firstly develop the machine learning model. Starting with downloading the dataset, we then read the dataset after importing the required libraries. We then clean the dataset and we have dropped the columns seller and offer type because they were having the same entries. We then remove the cars having power less than 50p and greater than 900p, after which we remove the cars with the year of registration between 1950 and after 2017. After that, we remove the columns that are not relevant, for example, date crawled, last seen, postal code, and etc. We then clean the dataset of German words and then replace them with proper English words. We then remove the outliers and then we label and encode the categorical data. After that, we have split the preprocessed data into train and test sets.
We train the model using random forest regressor and decision tree classifier. We use the R-squared score metric to measure the performance of the models. We find that the R-square value of random forest regressor is more, meaning that it is a better model. We use the pickle dump function to save the model. All these processes are included under Sprint 1. Then Sprint 2 consists of developing the front-end web page that is used to receive the inputs from the user for prediction.
So this is the index.html code. This is the basic home page of our website. And after that, this is the input page, which is the main page of our website. Here we get the user inputs and the prediction is also done. So these are the associated CSS files. And then this completes Sprint 2.
The Sprint 3 is to develop the Flask application. We can first see the model which we dumped using pickle. The resale underscore model.pkl is the model we dumped earlier in the mission model building phase, that is the Sprint 1. Now we develop the Flask application. So the main.py file is the code which has the Flask application. So we use pickle to undump the model, and we have several render templates and several other functions which will be used to receive the input from user, that is through the front end web page, and we use the prediction model to predict the value of the output, and we then display the output using the same web page. So this completes the third sprint of the project. So the final sprint, that is the Sprint 4, consists of deploying the machine learning model in IBM Cloud. We can firstly we created an IBM Cloud account, and this is the resource list we have created for our project. Here we can see that we have a cloud storage to store the projects, a Watson Studio, and an associated Watson machine learning asset. So we can see here which are the buckets we have created for the project. So this contains the project files and the data set associated with the project. So when we then create a project in Watson Studio. So we go to Watson Studio and we launch the IBM Cloud Pack for the data. And this is the Jupyter Notebook code we have already developed, and I have uploaded the data set to the. We have uploaded the dataset to the cloud, and we also uploaded the Jupyter Notebook created. So to read the dataset which is uploaded in IBM Cloud, we write a separate set of code which is given here, and then we read the dataset. The remaining parts are the same as we develop the model, and the last part is where we deploy the model in the IBM Cloud. So this is the part where we deploy the model in IBM Cloud. We have added the code, and for deployment in IBM Cloud, we should create a deployment space. So for our purpose, I have created a deployment space called models, which is created in the Watson Studio itself. And this is the API key which we can get from the public access IAM of the IBM Cloud assets. So I have created the models, and I have also deployed the I have also written the code to push the model in the deployment space. So after deployment, we can see that the model is deployed. So for the model to be fully deployed, we should add the associated asset, which is the machine learning code we developed. So here we can see that I have added the associated asset, which is the Watson machine learning model, and I have deployed the code online. So this code is now available online, and here is the scoring endpoint of the deployed model. Now, what we should do is we should integrate this IBM and deploy machine learning model to the Flask application so that we can integrate the HTML web page and the deployed machine learning model. So I have copied the scoring endpoint here from here, and I have entered a certain set of codes into the Flask application, which will be used to connect the IBM cloud deployed machine learning model to the Flask application. So this is how it works, and when we the code is already running, and we can see that the deployed model is ready to run using the Flask integrated application. So this is the home page of the application. So when we click on car resale price, we can go to the page where we get the input from users. So let me enter the registration year, say for example 2002, and I let the other values be default. The power of car, I enter it as 190, and the enter the kilometers, I go 1,25,000. So the manual, car is damaged, snow, and I'm just letting all the values be as already given in the web page. So we can see that the predicted value is shown as $6,254.29. So this is how the project works, and we can see I just changed the value of power of current PS to 190 to 220. We can now see that the value predicted is around $9,000. We have changed the input, and thus the output has also been changed.